entire section is
This
usually
call is now being recorded.
the entire section is usually around 30 marks, right? So you might have 30, 35 marks. So you might have your 20 marks from your first part of trigonometry, and then you have the other marks from sine rule, cosine rule, and the area rule. It's not a really difficult topic. The only challenge could be the proofs, but the more you do, the better. Right? Okay. So today we'll be doing, let me start here. Okay. So today we'll be doing your trigonometry. I mean not your trigonometry. I mean we'll be doing your statistics, right? So we'll be doing your statistics today. Um, can you guys see my pen? Is it visible? Can you see what I'm writing on here? Okay. So today we'll be doing statistics, right? Today we'll be doing statistics. So the outcomes of this lesson should be the outcomes of this lesson. One, right? You need to know the measures of central tendency, right? Um, you need to know the measures of central tendency. The measures of central tendency. You need to know the measures of the measures of dispersion. And you also need to know the 5-number summary. The 5-number summary. So this section is usually very easy, but it also goes with practice. It's usually the first question of your exam paper. So these are easy marks, like it's your easy 10, 15 marks that you can get from here, right? So yeah, this is what you need to these are the outcomes for for this lesson, right? So this is what we are going to cover for this lesson. Great. So what do we mean when we talk about the measures of central tendency? So your measures of central tendency, it's your mean. So let's start here. Your measures of central tendency, right? So when we talk about the measures of central tendency, we will be talking about the mean, right? This is your mean, right? This is your mode. This is your mean. This is your median, right? And then you'll have your mode, right? So we have to define what we mean by the mean. We have to define what we mean by the median. We have to define what we mean by the mode, right? So the mean, these two, most of the time, the mean and the median of the data, they both give an indication of where the center of the data distribution is located, right? So if you are given a set of numbers, right, you are given a set of numbers. So what the mean will tell you, the mean and the mean and the median will tell you where your central or your center of the data is located, right? The center of distribution of that data is located. So that's what. So when we talk about the mean and the median, what needs to appear or what needs to register in your mind is the center of data, right? So it's not the same thing, but the idea is that it gives us where the center is, the set or the set of center of the data is, right? And then the mode, what you need to think of when you think about the mode, it's most, right? It's the number that appears the most, right? It's the number that appears the most. So let's define them properly, right? So the mean or the mean, which is also called the average, right, is usually calculated by, is given by x bar, right? X bar is equals to the sum, I is equals to n, right? Xi divided by n, right? So xi, what is xi? Xi is the data, right? Xi is the data, and then n is the number of data, right? So the average, so let's say for an example, right? Let's take an example. When we talk about the mean, let's say you have numbers 1, 5, 3, 7, 4, right? So what this formula means, if you want the average, right? So xi on top, right? This means that is the sum of data, right? So you say average is equals to is the sum of data, right? Divided by the number of data, right? So in this case, you are going to compute it as 1 plus 5 plus 3 plus 7 plus 4, right? Over the number of data. The number of data is how many numbers in that data do we have? So we have 1, 2, 3, 4, 5. We have 5, right? And then you press your calculator, you are going to get your mean, right? So in this example, if you press your calculator, you're going to have 1 plus 5 plus 3 plus 7 plus 4 over 5, right? Which gives you your 4, right? So this is what we mean by the mean, right? This is what we mean by the mean or the average. So the mean or the average is the sum of data divided by the number of data, right? And then now, when we talk about the median is the middle of data, is the middle value of an ordered data. So the median, the median, right? So if you want the median, you can calculate the median as usually n plus 1 over 2. So where n represents the number of data. So n will, in this section, will represent the number of data, right? So that's what is going to represent. That's how you find your median, right? And then your mode. So if you are given, like in this case, to find your median, you are going to say it's going to be 5 plus 1 over 2. So that means your median lies, so it's going to be 5, right, plus 1 over 2, which is going to be 6. 6 divided by 2 is going to be 3. Then you come here, you count. So it's 1, 2, 3, right? So that means this is your middle number, right? That means this is going to be your median. This is going to be your median. Great. And then your mode is the number that appears the most, right? So your mode is the number that appears the most, right? That appears the most, right? So maybe, for example, if you are given 1, 2, 1, 5, 7, 1, right? So if you want the mode here, your mode, so you check which number appears the most here, right? It's going to be your 1, right? You have 1, you have 1, you have 1, right? So your mode is going to be what? Is going to be 1. So that's how you find your mode, right? And then let's go to the measures of central dispersion, right? The measures of dispersion. Great. So the measures of dispersion, they tell us how spread out the data set is, right? Remember what we said about the measures of central tendency, right? They tell us about the distribution of data around the center, right? But the measures of dispersion, they tell us how spread the data set is. So if a measure of dispersion is small, then the data is clustered around a small region. If a measure of dispersion is large, then the data is spread out along the over a large region. So the things that you need to think about when you talk about the measures of dispersion, you talk about the range. You think about the range, right? And then you talk about the interquartile range. Your interquartile range. Right. So what is the range, right? So what is the range? Okay, so let's come here. What is the range? So the range is given by R is equals to the maximum value minus the minimum, right? So that's how you calculate the range. So the range is the minimum value minus the maximum value minus the minimum value, right? So for example, let's say you are given a data set of 1, 7, 5, 9, 15, 2, and maybe let's say 6, right? So if we want the range here, we need to have the minimum number. Let's start with the max, right? And then let's check the mean, right? So we come here. The first thing that we do, we are going to identify the maximum number, right? So in this case, the maximum number is what? Is 15, right? And then the minimum number, it's definitely going to be 1, right? So you write that 15, you write 1, right? So for you to find your range is going to be your 15 minus 1. Right. So that's how you find your range, right? And then let's go to the interquartile range. So here we are going to talk about 3 things. We are going to talk about Q1, Q2, and Q3, right? But your interquartile or your interquartile range, right? So your interquartile range in simple terms is given, it's your, so usually it's going to be written by IQR is going to be your Q3 minus your Q1, right? That's how you are going to get your, that's how you get your interquartile range, right? So, but we have to define what is Q3, what is Q1, right? What is Q3, what is Q1? Those things you will see them better and how we apply them more on when we do a box and whisker. So for now, let's just make an example, right? So let's say you are given this is your minimum value, this is your maximum value, right? And then here, this is how you are going to have it, right? This is your box and whisker. We will explain it more when we get it to it. So this is going to be your Q1, this is going to be a Q2, this is going to be a Q3. So in number terms, right? In number terms, you can call this 0, and then maybe you can call this 1, right? So this is your 1/2. This is your 3/4, right? This is your 3/4, and this is your 1/4, right? That is your 1/4. So that's the best way to visualize this, right? Is to say your Q1 on a box and whisker is a quarter of the data. Your Q2 is your center, and then your Q3 is 3/4 of the data. So that's basically how you can best remember it, right? So that's your interquartile range. When we talk about the interquartile range, this is what you need to remember. And this is how you find your interquartile range, right? It's your Q3 minus your Q1. And now we are going to move to the 5-number summary. So the 5-number summary is the 5-number summary is your measures of dispersion plus the measures of central tendency. So it's easy like that. You just calculate them in that way. So let's, or maybe I need to give you formulas for Q1 and Q2, right? So to calculate Q3 is going to be given by, remember what I said, right? I'll show you here. Let's do this. Your interquartile range, right? So your IQR, your interquartile range. Remember what we said, right? That if we have numbers, right? And then we have 3 things. This is your 0. This is your 1, right? So the middle between 0 and 1 is just 1/2, right? And then this is your first quarter, which is 1/4. And then this is your third quarter, right? Which is 3/4, right? And we said that the interquartile range is calculated by IQR is equals to Q3 minus what? Q1, right? So this is going to be your Q2, this is going to be your Q3, and this is going to be your Q1. Right, so this is how you calculate your interquartile range. And then how do you find Q3 and how do you find Q1, right? So Q1 is going to be your 1 over 4, that 1 over 4 there, and then you just put n plus 1, right? And then your Q3 is going to be that 3 over 4, which is 3 quarters. It's going to be your 3 over 4, what? N plus 1, right? So that's how you are going to find your Q3 and your Q1. So these are very important. You don't have to claim them, as I've already showed you what they mean. This is your Q1. This is your Q2, right? This is Q1, Q2. I mean Q3. Then for those who are interested in knowing, then your Q2 is going to be your 1 over 2 n plus 1, right? Easy like that. It's going to be easy like that, right? So now, when you talk about a 5-number summary, right? Because sometimes the question can ask you to give the 5-number summary, right? So when you talk about the 5-number summary, you are going to talk about the measures of measures of central tendency and the measures of dispersion, right? So your central tendency, remember what we said it's the mean or the average, right? And the median, right? And then we combine it with what? Combine it with your range, which are the measures of central dispersion, your interquartile range, which is your IQR, right? So from your IQR, you are going to get what? You are going to get your Q3, right? Minus Q1, right? So this this is what we mean by the 5-number summary. The reason why it's called a 5-number summary is because when you break down IQR, right, the interquartile range, you are going to get 3 things. You are going to get Q1, you are going to get Q2, and then you are going to get Q3, right? This is your lower quartile. This is your lower quartile. This is your middle, right? And then this is your upper quartile range. This is your upper quartile range, right? So if you don't want to use that IQR, you can simply just say you are going to have your median, right? Your median, your mean, your range, your quartile, your lower quartile, right? Remember, we don't count this. 5, right? So the reason why we don't count this, remember, your IQR. What is your IQR? Your IQR is Q3 minus Q1, right? So basically you have 1, 2, 3, 4, 5. So you don't usually count the middle quartile from the measures of central dispersion. Right. So this is your 5-number summary. So this is just as easy as it gets. Do we have any questions for now before we move on to the box and whisker, box and whisker, box and whisker? If you have any question, you can gladly tell me. Or if you don't have any question, if it makes sense what we are covering or what we've covered so far, you can just give me a thumbs up. Okay, thank you. So now we are going to to your box and whisker, right? Your box. We are going to go to your box and whisker, right? So your box and whisker is very simple. It's a representation. It's your representation of a 5-number summary, right? What is your 5-number summary? Remember what we said about the 5-number summary. 5, your 5-number summary, right? You are going to have your range, right? You have your range, you have your mean, you have your median, and then you have your IQR, right? You have your IQR. So from IQR, it's your Q3 and your Q1, right? So this is what we mean by box and whisker, right? This is what we mean by box and whisker. You have seen this before. I'll just write it here. Right? So the things that, okay, so the best way you can do this is that from here, you are going to get your max minus your mean, right? And then your median should be in the middle, right? You can just say, no, not the median, I mean, the median here, it's your middle, right? So, for example, right, how you are going to represent this is that this, you are going to treat it as, this is going to be your mean, right? Which means this is where your minimum value will be. And then this is going to be your max, right? This is going to be your mean, this is going to be your max, right? So this one is going to be your Q1, right? And this is going to be your Q3, right? It's going to be your Q3. And then here, it's going to be your median. It's going to be your median or your Q2, right? Remember what I told you about your median, right? Your median, where is the median? Median is n plus 1 over 2, and this can also be written as 1 over 2 into n plus 1, right? So this 1 over 2 n plus 1, right? It's the same as this 1 over 2 n plus 1, which means that your median is also equals to Q2, right? So you have your Q1, which is your lower quartile. You have your Q3, which is your upper quartile, and then you have your median, which is also equals to your Q2, which is your middle quartile, right? And then what this means is that from here, you get your IQR, which is your interquartile range, right? So this is how you draw your box and whisker. We are going to do an example where you see how we draw your box and whisker. But the first thing that comes in here is your minimum. You are going to also have your maximum. And then you are going to have your Q1, Q2, Q3, and interquartile range. right? So your median, remember what we said about the median? Your median is given by 1 over 2n plus 1, right? But also your Q2 is also given by 1 over n, 2 plus 1, right? Which means that your median is also equals to your Q2. So here you can write, instead of writing median, you can simply write Q2, right? Or you can write the median. It's the same. It depends on you, right? So let's write it properly here. You can either write median or Q2. Does that make sense, guys? This is all that you need to know from the measures of central tendency, the measures of dispersion, and then the 5-number summary, right? I will show you when it comes to interpretation of these things, right? Because sometimes you'll get that. So this one, you'll get a Boston and whisker that looks like this one. Your Boston whisker can look like this, right? Or it can look like this. Or it can look like this, right? So if you haven't seen the difference, I'll show you the difference now. The difference between these three things, right? Between 1, 2, 3, is the distribution, right? So as you can see, that is marked in red is bigger than this one. Is bigger than the one marked in blue, right? Here, they are almost symmetric, right? So here they are almost symmetric. They are almost symmetric. And then here, you can see that the one in blue is greater than the one in red. I'll show you because you need to know this, right? Remember that the Boston whisker is a representation of a 5-number summary, which tells you how your data is distributed right around the mean, right? So the reason why we have this, right, is to tell us how the data is distributed around the mean. So that those are the things that we need to know, right? So maybe before we go into interpretation of this, let's redraw this and then I explain what they mean, right? Your box investor differences, right? So this is your box investor again. Great. So let's start with the first one, right, which is your normal distribution, right? As you can see here, right? So I can easily say this is actually equals to that, as you can see, which means it's symmetry, right? That's what we mean. We don't mean by numbers, we mean by it's symmetrical. Symmetrical, right? So this means that your data is normally distributed. Is normally distributed, right? Which means that the data is symmetric. Normally distribute, normally distributed, right? And then the second one, is when we have something that looks like this, right? In this case, we can say your data is positively skewed, right? Because it's skewed, it's not distributed equally. So we can say it's positively skewed. So it lies more on this side, right? So we say it's positively skewed. Positively skewed. Great. So the last one, we'll draw it on the other section. The last one is this one.
Question
Do you have a question?
is
Okay, I'm
uh,
listening.
about the uh, about the skewness. You can see to the right or to the left, or positive, negative.
Yeah, so it's either usually, you know why I like positively skewed, right?
Mm.
Positively skewed, it's easy for you. When you visualize it, right? Take for a number line, right? You have
Yes.
your zero. This is your positive side, right? This is your negative side. So usually when you have let's say you have your 1, 2, 3, 4, 5, right? And then here it's going to be your -1, your -2, your -3, your -4, right? So the reason why I like positively skewed, right? It's because it's easy for you to see, right? If you have more of positive, right? So if if this side is, so you can just draw a number line here and say this is your zero and this is your positive, this is your negative, right? So the one that is bigger, you can just say it's positively skewed, right? But if it's easy for you to say it's, what did you say, right? It lies more on the right, or it lies more, or I mean, rightly skewed or leftly skewed. You can say it, right? But I'm gonna ask you to keep it to positively skewed or negatively skewed. You won't be incorrect by saying it's leftly skewed or rightly skewed, but I think positively skewed sounds more better, right? Because
Mm.
you are doing mathematics, right? When you visualize a positive, where do you see your positive? You see your positive when you draw a number line, this is your positive side, right? So the one that is bigger, it means that's where your data is distributed mostly, right? So you are going to say it's positively what skewed. And then when it's the other way around, when the negative side is bigger, you will just say it's negatively skewed.
Yes, yes. Thank
So,
you, sir.
so you understand it now.
Yeah.
Okay. So the wording does not really matter. The what matters mostly is understanding. Do you understand what you mean by saying it's left or it's right? It's right, right? So in this case, you don't even have to cram, right? If you forgot, you just draw your number line, right? You say zero, say negative, you negative, and then you see how your thing is distributed, right? And then
Yeah.
when you see that the positive side, which means the right side is bigger, that means it lies more on the positive side, right? So you can say it's positively skewed, even if you don't remember, right? It's better to think in a mathematical way, right, than to just think of things randomly. Because what happens if you forget what left means, right? But as long as you understand, right? Um, as long as you understand that's not gonna be a problem. What's important is understanding. So now we move on to the negative skewness, right? Yeah, I exaggerated this. Okay, right. So this is negatively skewed, right? Negatively skewed, right? Remember, you don't forget when you draw these things, this is always your mean, this is always your max, and then this is your Q1, this is your Q2, this is your Q3, right? In everything that you do. This is your mean meaning minimum, max. This is your Q1, this is your Q2, and this is your Q3, right? And then mean, max, Q1, Q2, Q3, right? So that's how you can think of it. So even here, if you don't understand it properly, or if you forgot how you can think of it to see if it's negatively skewed, you can just make a number line, right? And you say this is 0, and then this side represents your negative side, this side represents your positive side, right? So if they say comment about the skewness of the data, right? You look at what is bigger, right? You always look at what is bigger. So you see that this side is bigger, right? So the easiest way is going to be negatively skewed, right? Your teacher can teach you in a different way about using the Q1, the Q2 and the Q3 ranges, right? That if the range, right, if Q2 minus Q1 is greater than Q3 minus Q2, right, then they will say it's negatively skewed. It's negatively skewed. Usually I don't like this, right? I don't like this because it's very easy for you to forget this, right? So maybe they can teach you that it's Q3. I mean, if your Q2 minus your Q1, right, which is this, is greater than your Q3 minus your Q2, right? That means it's negatively skewed, right? It's negatively skewed, right? Because the number that you will get here is going to be bigger than the number that you will get here. So the difference in numbers that you will get from here is going to be bigger than this one, right? So your teacher can teach you about this method, right? But I feel like you don't get marks for writing this, right? So there's no point in actually knowing this, because writing this won't give you marks, right? You have to comment on the skewness. So then what gives you a mark is writing correctly that something is positively skewed or it's negatively skewed, right? So for an example, if you make a mistake and you put Q3 here, right, that means your answer is going to be wrong, right? Because you will get wrong numbers, and it means you might say it's positively skewed in saying it's negatively skewed, right? So I usually don't support that method, right? I usually teach my learners to get what is needed, right? Or to know what is needed. And then if you want to maybe study mathematics one day, you can go further into that, right? But what gets you a mark in a question is saying something is negatively skewed or positively skewed, right? Or it's symmetrical, right? And the easiest way is you draw your box and whisker. After drawing your box and whisker, you visualize your box and whisker, and then you can draw it, right? But if you don't want to draw your box and whisker, then you can use this method, right? You can use that method that I showed you, if Q2, Q3, and what, right? But usually when they ask you about these questions, right? When they ask you about these questions, they will ask you to draw a box and whisker for the data, and then they will say comment on the skewness of the data, right? So that's how you are, most of the time you are going to be asked to do it. So I'm gonna upload one question that we are going to do. I want to upload one question that we are going to do, and then yeah, I'm gonna stop sharing my screen now and then upload that question. Let me see. Oh. Okay, that's fine. Great. Can you guys see the question? Is it visible enough? Oh, I didn't know I can. We'll do 2 questions. Can you guys see this question? You can just give me a thumbs up. Okay. So as I've already told you, right? Most of the time when you get a question, and this is from a previous question paper, right? Most of the time when you get a question, it's either they will give you a set of numbers like these ones, right? Do you want to say something?
I can't see the numbers.
Okay. Can you see them now?
Yes.
Okay. So most of the time in an exam question, and as you can see, this is just an easy 5 marks, right? Easy 5 marks, it gets you going, it gives you the confidence, right? So as I've already said, before you even start reading the question, you most of the time you'll be given a set of numbers, right? And then you will be asked to draw this, right? To draw the box and whisker, and then you will be asked to answer the questions, right? So the first thing, if you look at this question, before you read the statement, write down the 5-number summary of the data, right? I've already told you about the 5-number summary, right? The 5-number summary, you know It's your range. It's your range. It's your mean, right? It's your median. And then it's your IQR, right? And then they say determine the interquartile range, right? You do the same thing. That's why it's 2 marks. You do the same. That's why it's 1 mark on me. You do the same thing. Your IQR is going to be your Q3 minus your Q1, right? And then comment on the skewness of the data. It's very easy. I've just told you. You just do this and you do this. This is your 0, right? This is your positive side. This is your negative side, right? Which one is bigger? It's this side. It's 1 mark, right? So the reason why I said there's no need for you to know these things like your Q2 minus your Q1 greater than your Q2 or greater than your Q3 minus Q1, right? Only for you to get the wrong answer, right? So this is not necessary if you are going to get the wrong answer at the end. If making a mistake, because the margin of error here is bigger than here, right? So you are more likely to going to make a mistake here than you are going to make a mistake using this method. So please try to use this one, right? Try to use this method. It's actually the best way of getting 1 mark, right? You don't have to overwork yourself for 1 mark. So from here, you have not even read the statement, right? But you already have your 5 marks, right? But let's read the statement. So they say Brown conducted a survey on the amount of airtime in rands. Each student had on his or her cell phone, right? He summarized the data in the box and whisker diagram below. Right? So in this case, they've already drawn a box and whisker diagram for you. Right? If you didn't have a box and whisker diagram, right, then maybe this question was going to be out of what? Because they were going to give you 1 mark, 1 mark, 1 mark, 1 mark, 1 mark, right? They were going to, so this question was going to be out of 8 marks, right? So they've saved you. In fact, they were stingy with marks. They are only making this question, right? I mean, 4 marks. So this question would have easily been 10 marks, right? 10 marks if you didn't have your box and whisker diagram, right? Great. So in this case, they are saying write down the 5-number summary for this data, right? The 5-number summary for this data. So in this case, right, what is your range? Remember what we said about the range, right? Range is your max minus the mean, right? So the first thing that you do here, you do this, right? So someone will ask, right? Because this is not clear in this case, right? Where this one lies, right? I hope you will be able to see. So your minimum value, your maximum value in this case is going to be your max here, right? So it's gonna be 65. I'm not sure if you'll be able to see. It's in the middle, right? It's in the middle. So it's gonna be your 65 minus, and then your minimum value is going to be this one. It's 12, right? So it's going to be your 65 minus 12. So your 65 minus 12, right?
53.
Okay, 53. Right. And then they are also saying, and then your let's go to your first things. Let's calculate your Q1. Remember, for IQR, we need your Q3 and Q1, right? So in order for us to get that, we're going to need Q3, right? What did we say about Q3, right? I told you that you don't have to cram this, right? This is where you find your Q1, your Q2, your Q3, right? So if you draw a number line, right, this is going to be your 3/4. This is going to be your 3/4. This is going to be your 1/2. This is 1/4, right? So what is your Q3? It's 3/4 n plus 1, right? What is n? It's the number of data, right? The number of data that we have. And then your Q1 is going to be your 1/4 n plus 1, right? And then from here, you count the number of data that you have. You're going to count your number of data that you have, and then you add 1, and then you are going to find your Q1. You are also going to find your Q2, and then you subtract, right? You are going to say Q1 minus Q2, right? And then your mean, remember what we said about your mean or your average is what? It's the sum of data, right? The sum of data over the number of data. The number of data. So what you do, you sum these numbers and then you divide by the number of these numbers, right? And then you'll get that. And then on the skewness, we've already commented on the skewness, right? What do you do when you comment on the skewness? You just do this. It's very, very simple, right? You don't draw it like how I drew it now. You just draw it like this. You draw it like this, right? This is your negative side. This is your positive side. So what does this mean? This means that this data is what? Negatively skewed. Negatively skewed, right? Very simple, right? I'm trying to look for this question that we can do for the last 5 minutes. I didn't find it, right? Because the other question that I had opened had standard deviations, and we have not covered those standard deviations. So let me see if I can find it so that we can be able to do it and complete this lesson. It's also, these are the type of questions that you are going to get. It's easy, 10 marks, right? So let me see if I can get that question quickly. I'm gonna have to write down the question because I'm not finding it on my tablet. Right, so let's just do this question for the last 5 minutes. Yeah, so they are giving us 4, 86, 27, 21, 29, 37, right, 29, 44, 31, 42, 35, 38, 41, 29, and 40, right? So they are saying, I will add this question when I send the note so that you can see it. So the first question is determine the mean, right? So this question is a question for, it's not an exam question, but it's a question that covers what will be covered in the exam. So it's a question that has many questions there. So it's good for practice. So the first thing is that determine the mean, right? So remember what we said about the mean, right? So the mean is the sum of data. It's the sum of data divided by the number of data, right? The number of data. So, okay, let's just do it. So we can say 4 plus 86 plus 27 plus 21 plus, so that's how you do it, right? You add those numbers, 420 plus 29 plus 37 plus 44 plus 31 plus 42 plus 35 plus 38 plus 41 plus 29 plus 40, right? So you can verify with what the numbers that you get. So how many, the number of data, right? The number of data is how many data do we have? How many number of data do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It's over 15, right? And then you will get your answer as 33.6, right? That's your mean. And then your mode, remember what we said about the mode. The mode is the number that appears the most, right? The number that appears the most, right? The number that appears the most. So which number appears the most in this case? You go and look, right? So for me, the number that I see appearing the most is your 29, right? It's 29, right? You have 29 here, you have 29 here, you also have 29. So you come here and you write that your mode is what? Is 29, right? And then they are saying they want the median now. So the median is going to be your 1 over 2 n plus 1, right? So you have your 1 over 2 into 15 plus 1, right? So you actually have 1 over 2. This is 16, right? This is the same thing as 16 divided by 2. So 16 divided by 2 is 8, right? So that's your median. Now, they want the draw a box and whisker diagram for the data, right? So remember how you draw a box and whisker diagram for the data, right? If you are to draw a box and whisker diagram, box and whisker, right? This is what you do, right? You can start, you know that you will need your mean, you will need your max, you will need your Q1, you will need your Q2, and then you will need your Q3, right? So you can do it. I see that someone raised their hand. Kando raised their hand.
Yes,
Yes.
for median, the answer that you get, isn't it the position?
Say again.
For median, the answer that you get, isn't it the position?
Oh yeah, it should be the position. Sorry about that. So this is 8, right? So you have to go here and count 8, right? So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. That means your median is 44. Sorry about
Don't
that.
you arrange the numbers first from smallest to biggest?
Do you arrange the what? I thought
The
they were
numbers.
already arranged. They were not arranged as yet. Let me
No.
see. Oh yeah. Oh yeah. I'm sorry about that, guys. But this one is still correct. Also this one is still correct. I think here I made a mistake about that. So the first thing that you do is that when you are given a set of numbers that are not arranged, you have to arrange them um, from the smallest to the biggest. Sorry about that. Thank you, Tano, for that. Yeah, I missed that. I made an assumption that this data is already arranged. So what you are going to do, okay, we can do that. So you have your 4, right? You are going to arrange it, and you are going to have your 4, and then you are going to have your your 21. You are going to have your 27. You are going to have your 29, 29, 29, right? And then you are going to have your 31, and then you are going to have your 35, 35, and then you are going to have what? 35. It's going to be 38. No, it's going to be 37. And then it's going to be 38. Then it's going to be 41, 42. And then, nope, it's going to be 40, 41, 42, and 44, right? So the mean is still correct. The mode is still correct, right? So the median, right, we said it's going to be 1 over 16 over 8. So now your 8 is going to be your, let's see, 1, 2, 3, 4, 5, 6, 7, 8, right? So that changes. So it's going to be your 35, right? So this is where you get your, oh, what happened now? Yes, so this is going to be your, this is going to be your median, right? It's 35, right? So now we can move on to the box and whisker, right? So the first thing that you do in a box and whisker, you just visualize it first, right? It's going to be your max, your mean, your max, your Q1, your Q2, your Q3, right? So for you to find your mean, right? Your mean, it's your minimum value here, which is going to be your 4, which is this one. And then your max is going to be your 44, right? Which is this one. And then your Q1 is calculated by saying 1 over 4 into n plus 1, right? So that means it's going to be your 1 over 4, 16 plus, 16 plus, no, 15, which is going to be 16, right? So 16 over 4 is going to give you your position, right? Which is 4, right? So this is 1. You go here, you count 1, 2, 3, 4. That's 29, right? That means your Q1 is 29, right? You do the same for Q2. You do the same for Q2, which is going to be 1 over 2 into 16. Why is it 16? Remember, it's 15 plus 1, right? Which gives us 16. So it's going to be your 8, which is going to be 35, right? Because we had already calculated it to be 35, right? And then your Q3 is going to be your 3 over 4 into n plus 1, which is 3 over 4 into 15 plus 1, right? So 3 over 4 times 16, right? It's going to be 12, right? So you have, wow, you come here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right, that means it's 41. It's gonna be 41, right? So the final box and whisker is going to be something that looks like this, right? You have your Q1, which is 29, 29, and then you have your Q2, which is 35, and then you have your Q3, which is 41, right? So if you go and draw this, you are going to have something looking like this, right? So your minimum value, we had already said that is what? It's 4. And then this one is 44, right? And then your Q2 is 35, right? And then your Q3 is 41. And then this is 29, right? This is 29. So this is how I've drawn it, right? Which means if you draw this, right, it's not clear because I did not draw it on into scale, right? But the easiest way in which you can do that, you can say 35 minus 14, 41 minus 35 is going to give you 41 minus 35 is going to give you 6, right? That means the distance between here and here is 6. And then you can also say 35 minus 29. It's going to give you 35 minus 29. It's also going to give you 6. So what you can say is that this side is equals to this side, right? In terms of distance. So the last question is comment about the skewness of the data, right? So you can say this is normally distributed, normally or equally distributed. Or equally distributed, right? So yeah, that brings us to the end of our lesson, guys. So a summary of this is that the things that we have covered today. So let's just do here. So the summary of what we have done today is that we covered the measures of dispersion, right? The measures of dispersion. We also covered the measures of central tendency. Right. And then we also covered what? 5-number summary. 5-number summary. Right. So when you want to answer questions, right? When you want to answer questions, the first thing that you do is to arrange data. If it's not already arranged, right? Remember the previous question, we didn't arrange it because it was already arranged. So you arrange the data from small to biggest, right? And then from there, you can start answering your questions. From there, you can get your mean, you can get your max, right? And then when it comes to your quartiles, right? Your Q1, which is 1/4n plus 1, right? This will give you the position, not the answer, right? If your data is not already arranged. And then 1/2 plus 1, it will also give you your position. And then from there, you go and count the numbers, right? the same is true for this one, which also gives you your position, right? So when you have your position, from your position yakho, you can then go count the numbers. Count the number and find the answer. Count the number and find the answer. Right? Yeah. So this is just it. These are your easy marks, guys. I will combine a list of questions that we are going to do, and then I will upload them with these notes, and then you will do them as part of homework. And then when we meet tomorrow, when we meet next time, we are going to do those questions, and we're going to move on to the other concepts. So the plan is to finish statistics this week, right? So make sure that you are available. So next week we are going to do the other concepts, and then we'll do more questions, and then we'll finish up this section, right? And then on our another session this week, we are going to do practice questions for statistics, and then we are also going to do practice questions for trigonometry, right? So that you make sure that by the time you write your test or you go to write your exam, you just do your revision, but you have already grasped the concepts. Yeah. So that's it from me today, guys. Thank you for joining until this time. Please make sure that you avail yourself for the next session. Thank you, guys.
Thank you, sir.
Okay. Okay, bye, guys.
Bye, sir.
Bye.